Okay, so this is problem out of the book. We did was assigned number 25 on page 321. So this is number 25 on page 321. Okay? So this is really an easy question if you get it on the quiz. You'll have one like this. This is probably a 6-point, 7-point question. And you should be able to get it done in probably about 5 minutes. Shouldn't take you more than 5 minutes to do a question like this. Okay? Should be really easy. One thing makes it easy, they're all ones. 1, 1, 1, 1 all the way across. So that makes it really easy because you already know your x. It'd be the smallest number of moles. Because it's a 1-to-1 relationship, your smallest number of moles is 2.5. So you already know your x. You don't have to divide anything out. You don't have to solve for it because we don't have 3 in front of one of the balanced equations. We know that 2.5 will be our x. So what we'll do is we're going to go ahead and do the change. The change means that we are going to reduce how many moles we have on the reactant side so that we can make product, and that will be added product after the reaction's done. So the change means how many moles have to be subtracted. So we represent that by minus x. Minus x, and if we had a 3 in front of copper, that would be a minus 3x, but that's not the case here. These would be plus x's. Okay? So I've noticed today, looking at students' work, that they don't take into account 1s or 3s and 4s in front of the product, and so they just make it plus x maybe when it was supposed to be plus 3x if there's a 3 there. So in this case, we don't have to worry about that. Next case, you'll kind of see you're going to have to take that into consideration. Okay? So now all we have to do is we take the I and C and we subtract out our moles. So it'd be 2.5 minus x. See, we just line it up, 2.5 minus x. That's how many moles will be subtracted from copper. Then we're going to take 5.5 moles minus x, and that's how many moles are subtracted from silver nitrate. Be the same number of moles have to be subtracted from both of those. And then here it's 0 plus x, which is just x values for those two products. All right. So here we go. We know x is 2.5 because it's our smallest number of moles in our ratio. So x equals 2.5. So 2.5 minus 2.5 is 0 moles. So guess what? Copper's limiting. So that's the first question. Number 25, it says, identify the limited reactant. It's copper. You write that down. So there's our first answer. Say it's worth 2 points. Got it. 2 points. We keep on going. 5.5 moles minus x, which is 2.5. We end up with an answer of 3 moles. So question number 2, or question B, says determine the amount of moles of excess reactant remaining. 3 moles. That's our answer. See? How many moles are reacted of the silver nitrate? Only 2.5. And how much do we have left over is the difference between what we had to begin with and what reacted. So that's 3 moles. So that's the answer for B, 3 moles of AgNO3. Okay? The answer for C is determine the number of moles of each product formed. Well, it's 2.5. Okay? So 2.5 moles are formed of each product. So then you'd say 2.5 moles of copper nitrate, and then you'd say 2.5 moles of silver. That would be your answer for C. So There's 6 points out of 6 points that you get. Okay, we did it in less than 5 minutes. Okay, the last one is pretty easy as well. That one asks for how many grams. So D asks for how many grams are produced. So if we've got moles here, all we have to do is convert to grams. So we have 2.5 moles of copper nitrate. So for every 1 mole of copper nitrate, you'd add everything up. So copper is 63.546, and nitrogen is 14.01, and oxygen, when you add everything up, is 48. So that's 125.56. And you multiply that out. And then you do the same for silver. 2.5 moles of silver. Then you'd say for every 1 mole of silver, you would have 107.87. And then you'd get your answer for both of those. So if you did the work, went through, did letter D, then the answer for copper nitrate would be 314. And then for silver, would be 270. Any questions on that? Is that what you guys had? If you went that far? Some of you, I noticed on your, all you did was this part right here. And then you need to go and make sure you're answering questions A, B, C, D, and down. Okay? Any questions with that? So there's 8 points. 8 out of 8. Boom, I got it done. You should be able to get that done like in 5 minutes and move on to the next one. That's a lot of points in a short period of time that you get. Okay, any thoughts or questions yet? Now the next one looks a lot more difficult, but it's not that much different in the final outcome. But we had to make sure we have this balance. So to balance it would be 3 and 2 and 6, right? Okay. Sometimes students are using the 30 grams for their initial. Why would that not be a good thing to do? Got to have moles. So everything in the ICE are just moles. They're all moles. So what I'll do is I'll take 30, and most people in this class I noticed coming around, you had them right. This first one is 0.306 moles. Okay? And then the second one is divided by 78.01, and that's 0.320 moles. Okay, questions? How did I get that? I took 30 divided by the weight, molar mass of H2SO4, which is 98.10. And then for aluminum hydroxide, I took 25 divided by its weight, which is 78.01. And there's my moles. Okay? Then we start out with 0 moles of product. Alright? That's always going to be the case on these. The change is how much has to be subtracted from those initial moles. So I look up my balanced equation, and I have a 3 in front of H2SO4. So what's different from the previous problem is that this is minus 3x. Okay? So this is problem number 26 again that we're doing. Minus 3x minus 2x plus 6x. And then plus x. Okay? Questions on that? Okay? So that's my change. Now, I can only have one x value. The reason I take this 0.306 and divide it by 3 is to see how many moles I would have if it's just looking at H2SO4. Okay? And then the 0.320, I'm looking to see how many moles I would have available when I divide by 2. And both of those I have to do to calculate my x, to see which one I want to use. So down here I'm going to put 0.306 divided by 3, and that gives me 0.102. Then I'm going to take the 0.320 divided by its coefficient, 2, and I get 0.160. Now, this automatically tells me which one's limiting. At this point, I can answer the question. So which of the two, H2SO4 or aluminum hydroxide, is limiting? H2SO4, because it's the lowest number of moles. See, it's going to produce less product if I use that as my X. 0.160 is going to produce more product if I use that as my X. Well, I can't produce any more product than my limiting allows me to do, the 0.102. That one's going to be my X. Okay? So I'm going to let you work this out. Answer the 3 questions that go with it. Once you have that done, I check your answers. I'm going to give you another sheet to look at and work on, similar type of questions. So what you'll have to do is you'll have to go through this process to do these calculations to find out what your individual answers would be to limiting. We've already answered that one, H2SO4. There's another 2 points. You're going to have to find out how much is in excess in grams. This one's a little different because you got to take it a little bit further than the last one. And how much product is made in grams. So product made in grams should be really easy because we already know 0.102. So the amount of water produced is 0.612 moles. So then all I have to do is convert it to grams. And then for X, I know it's 0.102, and all I have to do is multiply that by aluminum sulfate's weight. Now that looks daunting, the 2 aluminums, 12 oxygens, and 3 sulfurs, adding those up, that's going to be a pretty big number, but you guys can do that. Okay? And then we'll give all the answers up here when you're done. Okay? When you're done with everything, I'll go ahead and put the answers down. So that's what you'll do. If you've got these answers already, I'll come around with the book, check them, and then I'll give you the assignment for tomorrow. You can start up working on today. Okay? Probably have a half hour to work on it today in class once you have those done.